Okay, so here's what we're going to do today. Last time we talked about the S rules, which were three rules of inference for three of the operators. Today we're going to give you four more rules of inference called the I rules. What is different between the S rules and the I rules is that the I rules require a combination of two kinds of statements that work together in specific ways. So having one on its own is insufficient to invoke an I rule. So our schedule is we're going to go over the I rules today. On Friday, I can't be here, so I'm going to provide a video on maybe an exercise for you to go over to highlight, again, some of the nuances with the S and the I rules to help give you a little more practice. Monday is our in-class review session, and a week from today is exam 3. You have to bring your own device. You're expected to take it here unless you've made arrangements otherwise. And that'll be exam 3. So yeah, that's the current schedule. That's the plan. Everything through today's lecture will be on the exam. Everything from exam 2 until today's lecture. Questions about anything logistical, anything schedule-wise? Yes. In class, we haven't scheduled yet a tutor-led review, but we will also try to get a tutor-led review as well. All right, so that's where we are today. So let's talk about three of the I rules, and I'm going to start with the one that I think is probably the hardest. The not both rule, sometimes called conjunctive syllogism, sometimes called negated and. You can call it any of those, I don't know what you're talking about. So you remember, the and rule is the easiest of them. If I tell you both A and B are true, then shockingly, you can infer that A is true and also B is true. But from negated and A and B, you can't derive anything by itself. What you need is a combination. You need the negated and statement, and you need an additional statement that matches one of the two halves. So this says not both. It is not the case that both A and B are both true. We need to add to that something like A is true. If we know that we can't have both A and B true, and we know that A is true, we can then infer out the opposite of the remaining half. So if I know that A and B can't both be true, but A is true, we know that B cannot be true. It's kind of like this. You're going to be making your schedule, like next week or the following week. Let's say there's two classes that you want, and they're both at exactly the same time. And I say, you say, I can either take theater appreciation or math 101. And I signed up for theater appreciation. Therefore, we can infer from that you're not taking math 101, because we know you can only take one of them. So this says only one of these can be true. And if we know one is true, then the other can't be true. Now to make it a little more, so and that works with either half. So you can get the match of the left side or the match of the right side. So from not A and B, you can match either the A or you can also match the B. And if you match the B, then you get the opposite of the remaining one. So you can do it with either side. It's equal opportunity, left-handed, right-handed, doesn't matter. Now, here's where people get a little bit confused, if that's not confusing enough. Let's say we add negations inside the negated and statement. If we do, the rule still works. And the rule is always the same. The rule is match one of the two sides. And it has to match both the letter and the negation or lack of negation. So from, it is not the case of not A and not B. If you can match one of the halves, if we add a not A, we can then get the opposite of the remaining side. So the remaining side here is not B. The opposite of not B is B. So again, the rule is with negated and, if you can match exactly one of the two halves, then you get the exact opposite of the remaining half. And that works with the left side, it works with the right side, it works if it's affirmative, it works if it's negative. But the rule is always, always, always with negated and, try to match one of the two sides. Questions? Yes, sir.
All right, so you basically just like crossing it off, like once you get like one of them, then it crosses off and then just like leaves the other one. So then...
Yeah, as long, I mean, that's one way to do it, so long as you remember to get the opposite of the remaining half.
All right.
So, you know, it would be tempting, you know, if it helps you to cross it off, that's great. Just make sure you remember, you don't just keep the B, you need to flip it to a not B. But if that helps you, more power to you. Yes, ma'am.
So in the third example, why was B presented before A, even though the A is negated and the fourth one, the A is negated, but presented first?
So why did I offer you that B? Because I want you to see that this works with either half. Because we won't always just work with the left half. That you can work with the right half as well. So if I say you can't have both A and B, and I give you a B, and that's the whole problem, that's all you're going to get. And then you have to look at that and say, well, gee, can I do something with that? And you'll say, yes, I can get the opposite of the remaining half. So when you get the problem, it's going to look like this. So that's why I gave you the B first, because I only gave you the B. I never gave you the A. You worked to get the A, or at least you will. Anything else? I start with this one, frankly, because I think this is the one that people struggle with the most. Because I think the other two are a little more intuitive. All right. Next, we have disjunctive syllogism, or you're free to just refer to it as the or rule. Now, you'll remember, we don't have a rule, an S rule for or. We have an S rule for negated or. So you remember the rule we have for negated or is this. From neither A nor B, you can get the opposite of both halves, not A and not B. But here, we're going to give you this. The first statement says either A is true or B is true, or either P is true or Q is true. We're going to negate one of the halves. And then you can infer out the remaining half. And it works with either side. Or to say it differently, when we say or, basically I'm saying either this is true or that is true. One of these two things has to be true. If I tell you one of these two claims has to be true, and we also figure out that one is false, whatever one we're left with must therefore be true. And it works with either side. So if I tell you, for lunch, let's say I'm the strict dad, for lunch, you will either have pizza or burgers, and you say, but Dad, I don't like burgers. Well, then I'm a good logician. I'm going to figure out, well, it looks like you're having pizza. And it works either way. You're going to have pizza or burgers, but I don't like burgers. Well, guess what? You get some pizza. So again, from an or statement means at least one of these has to be true. Once we eliminate one of the two possibilities, whatever is left must be true. Now, if this one, I find crossing out the one that we've got the opposite of helps. Because if I'm looking at an or, I need the opposite of one of the remaining halves. Once I do that, I'm left with the B. I bring that B down. Now, to make it more complicated, you're thinking, please don't, but reality makes it more complicated. This works with negations inside the parentheses as well. So anytime I have the opposite of what's in an or statement, I can infer that the remaining half is correct. So if this says either not A is the case or not B is the case, we need the opposite. The opposite here would be A. Well, then we infer out not B. So either not A is true or not B is true, but we know A is the case. A is the opposite of not A. You can cross those that A and not A out. We're left with the not B, and not B must be the case. Yes, sir.
What if it was just negation outside of the parentheses?
Oh, yeah. If the negation's outside the parentheses, you don't use this rule. If negation's outside the parentheses, you're still over here. So if negation's outside the parentheses, you can get the opposite of both sides of the or. So, and that goes with whatever is on each side. So if they're both already negative, then you switch them to positive. But yeah, the rule we're talking about today is for or without the negation outside. The rule I gave you last time was for an or with the negation outside. And today's rule is more complicated because you need the right combination of two statements. Yes, sir.
So it has to be the opposite, is that correct?
That's right.
So like for the very far right one, you couldn't put not equal on A, it had to be an actual.
Right. Matching is what you want to do with negated and. Opposite is what you want to find to use an or.
If you put the squiggly A, we put like nil, or we put mark out.
Yeah. If you had a squiggly A, then the correct inference would be nothing. No, that's correct. So again, for the or rule, you need the opposite of one of the halves. For the not and rule, you need the match of one of the halves to do an inference. So again, with the or rule, you're trying to rule one of the halves out. That's the way to think about it. And if you can rule one of the halves out, the remaining half must be the case. All right. Two more rules, both pertaining to arrow statements, conditional statements. Conditional arrow statements have two combinations that we can do an inference with. Remember, I gave you a rule for negated conditional last time. Now I'm going to tell you what to do if there's not a negation outside the parentheses of an arrow statement. The first one is called modus ponens. Modus ponens is when you have the combination of an arrow statement and the exact match of the left side of an arrow statement. And I think this one is probably the most intuitive of everything I'll talk about today. Because the arrow statement says, if you have an A, then you can infer a B. That's what the arrow statement says. Let's add to that arrow statement an A. Who can predict what we can infer out in this situation?
B.
That's right. How did you know?
Because it just goes.
Yeah, because it's common sense. If, the claim of the arrow says anytime you have an A, B must also be true. So once we tell you A is true, you can plug that into the arrow and you can get B. Now note, this arrow, how many directions does this arrow go in? It only goes in one direction. And because it only goes in one direction, what happens if I have a B? Can I infer anything? No, you cannot. Why? Because the arrow only goes left to right. It doesn't give you anything right to left. So matching the left side gets you the right, matching the right side gets you nothing. And it works with negations inside the parentheses. If the statement says, if I have a not A, then you can get a B, and I have a not A, then you can get a B. So again, if I can match the left side of what's on an arrow, I can get the match of the right side of the arrow. And that includes negations. But you have to match the negated or not negated nature of what's on the left. So if the left side says not A leads to B, we need a not A to get a B. Now I'm going to give you a second arrow rule. This is called modus tollens. Again, we have the same first arrow statement, if A then B. But now, instead of working with the left side, we're going to look at the right side. And we're going to use the opposite of the right side. So from the combination, if A then B, and the opposite of B, that gets you the opposite of A, the opposite of the left side. So this says something like, if I can save $10,000, I will buy a new car. And then you see me in a few months, and you see I'm still driving the same 2001 Camry that I've been driving for years. What would a smart person infer? Well, Silverman isn't buying a new car. He must not have saved the $10,000 he's been talking about. Probably smart not to bring it up. And it works with negatives as well. So if I have if not A, then not B, if I can find the opposite of the not B, so the opposite of not B is regular B. If I've got the opposite of not B, I can get the opposite of whatever's on the left side. The opposite of not A is A. So there you go. Fun things to do with arrows. In my experience, students are pretty good at the arrow statement. They find that to be pretty intuitive. But they struggle with the other two, with the or, and especially with the not and. That's my experience. All right, let's practice some problems together. And again, as we go, it's important that you make a prediction. I want you to play along. We don't have working software because IT hates my guts for some reason. Didn't pay my bribe this year. Maybe that's why I need to do grease and palms. But we'll work on this together. So let's say on the test, pretend you're taking a test. And we've got not W and T and the additional claim W. I want you to write down an answer, or if you did the homework and you can just go over the homework as we go. Now I want you to predict the correct answer. So from the claim, not both W and T and W, what can we get? Somebody give me an answer. What can we get?
Not T.
Very good. Yes, that is correct. Number 3, not T, is correct. Because the first statement says it is not the case. We can't have both W true and T true. The second statement tells us that W is true. And what we're left with is T. And the opposite of T must be the case. So I think part of what's difficult about the not and is you have to find a match, and then you have to get the opposite. So some people don't want to do the opposite thing. But yeah, you need to find a match to get the opposite of what remains. How about this? What, if anything, can we get from the claim either S or L and S? Actually, the correct answer is nothing. Because for the or statement, we need the opposite of one of the two halves. And we do not have an opposite. So matching one of the halves doesn't do anything with an or statement. Matching helps with a not and statement. So one of the things that we have to remember is that there's a pattern. And you have to remember each operator has a slightly different pattern. So what will work for not and is not what will work for an or. So for an or statement, we want the opposite of one of the halves, and we're left with the remaining half. But we don't have that here, so the correct answer is nothing. And in my experience, about 30 to 40% of the students get this wrong the first time they try it. How about this? If H, then not B. And a second claim H. Everyone write down their answer. All right, give me an answer. What's the right answer? That is correct. Yes, thank you very much. So yeah, the arrow statement, I think most students find a little intuitive. This says if you can find an H, you can get a not B. And here we gave you the H, you plug the H into the left side, and you infer out the exact match of the right side, as our gentleman did. So we got a not B. Very good. How about this? If X, then E. Give everyone a chance to record an answer. It's important that we all make an effort and play along. All right, you want to give us an answer?
Nothing,
That's right. The correct answer is nothing. Why?
because having E doesn't say anything about this.
Good. With an arrow statement, you either need to match the left side, you need an X, or you need the opposite of the right side, which would be a not E. And we got neither of those. So we get nothing. All right, let's try a hard one. Not both B and S, and not S. Everyone attempt an answer.
Nothing.
Nothing. Right, why?
Because as being false isn't like exactly
Good. What you need with an indicated and is you need to do an exact match of one of the two halves. The halves are affirmative B and affirmative S. So we need one of those two, and we do not have either. Therefore, we can get nothing from this, this problem. Next one, if not Y, then K. And the additional claim Y.
Nothing,
Good, why?
because you have to match either the left side or the opposite of the right side.
Right, and what the Y is, it's actually the opposite of the left side. So it doesn't help us. Because the first statement tells us if we don't have a Y, we can get a K, but it doesn't say anything about if we have the opposite of that. K or not R, and the additional claim R. What, if anything, can we get from that? Yes, sir. Yes, that is correct. So when you see an or, we are looking for the opposite of one of the two sides. R is the opposite of the not R. They basically cancel each other out. And whatever is left, we can infer. So in this case, we are left with a K. Very good. All right, how about this mess? Not both, not S and W, and also not W. What, if anything, can we get from that? Good, good. That is correct. So what we need is, since it's a not and, we need a match. And we don't have a match. Not W is the opposite of W. It is not B rather than the match of W. All right, let me pause. How are we doing with this? How are we doing? Show me fingers. Scale of 1 to 10. 10 means you got it. 1 means you're lost. Thumbs up, it means is good, right? Yeah. All right. So Looks like you're mostly getting it. Yeah, again, I wish I had the clicker data. My experience is the students do really well with the arrow statements, but they struggle more with the not and the or. All right, let's do a few more. Either not I or K and the additional claim K. What, if anything, can we get from this? That's correct, nothing. The or tells us we're looking for the opposite. And the K is not the opposite, the K is the match. So because we don't have any opposites, we can't infer anything. Not N or not A, and the additional claim A. What, if anything, can we get? Yes, sir. That's correct, yes. So the or tells us we're looking for the opposite. A is the opposite of not A. We're left with the not N. Not N is correct. Very good. If not A, then not E, and the additional claim, not E. What can we get? What can we get? That's right, nothing. With the arrow, we either need the exact match of the left, we need a not A, or the opposite of the right, we would need an E. All right, well, I feel pretty good about where you all stand on this. Do you have questions about this?
It was back on one of the not both questions where it was not parentheses, not S and W and parentheses, not W.
Right.
Wouldn't so are we? So I'm still confused about how exactly it doesn't work, because if we're trying to get it matching, then doesn't the outside negation make it matching?
Ah, yeah. So this is something that can throw people off if you're not careful. When you do the negated and, you only look at the negation long enough for you to know what I'm looking for here is the match along the two sides. Once you do that, put your hand over it and don't look at it anymore, because it can only confuse you. So you're looking for the exact match, and you look at that W, and this is not the match, that's the opposite. So I see why you would think, well, that maybe you should involve this negation. Don't do anything with this negation.
Okay.
So it's just there as sort of a flag to tell you negated and means I'm looking for a match. And that match includes the affirmative or negative nature of the letter. Anything else? All right, like other things in this class, this is an important building block for future stuff. After exam 3, we are going to do problems that involve much larger statements and involve many more steps of inferences. Right now, we're just doing one-step inferences. We're going to do stuff with 10, 15, and 20-step inferences. So we want these 7 rules, we want them mastered. We want them to get 95, 98, 100% correct. We don't want 80% mastery of this. We want high mastery of this, because everything that we do after exam 3 depends on you understanding this. In fact, I'm going to give you just a little taste. All right, let me show you. This will not be on exam 3, but I want to show you the sorts of things you can do with these rules. So we taught you the AND rule last time. The AND rule is really simple. If I tell you that both A and B are true, then A is true, and also B is true. The AND rule and all these rules work with statements regardless of how complex they are. So far, we've only been giving you 2-letter statements. But here is a statement with 6 letters in it. The outermost operator is the AND. The AND is the only operator that is only within one parenthesis. Therefore, this monstrosity is actually an AND statement. It says, if A then B, if and only if, either not C or D, and if not E then F. If you have that statement in a complex logical problem, you can invoke the AND rule, and only the AND rule, because you can only operate with the operator that is in the outermost parenthesis. So you can use the AND rule and infer the truth of both halves of the AND. You can infer the truth of if A, then B, if and only if, either not C or D, and also the truth of if not E, then F. This will not be on exam 3. But I want you to see it's important to master each of the basic rules, because we're going to do some scary stuff with it. And if you're still struggling with, am I looking for the match or am I looking for the opposite? When you see something like this, you're going to be in real trouble. So that will be for after exam 3. The other thing you need to keep in mind, and this you actually need to keep in mind on the test, is when you're presented with logic problems, we don't always tell you whether to look for an S rule or an I rule. You need to use your knowledge of the different operators, the negated or the negated and, or the regular arrow, or what have you. And you need to know and have memorized which rules go with which operators. And you need to remember that the negation or lack of the negation outside the parenthesis completely changes the relevant rules. So there is a chart, here, we can't borrow the book. There is a chart, I believe, and I will give you the exact page number in your book. It's at 6.12. It's on the top of page 143. There's a chart with the 7 rules I've taught you in 6 boxes. I would photocopy this. I would print it out if you're using an ebook. I would make 5 copies of it. I would put this everywhere. And I would make sure I understood down cold the implications of this chart. Because you'll need it for exam 3, and you'll need it for everything on exam 4. All right. Well, in that case, look for my email on Friday with the video link to help you again with some more S&I rules. Maybe I'll also post exercises. Come with your questions on Monday, prepared for our review. So your job on Monday is to know what it is you don't yet know. Actually, that's one of the keys to life, knowing what it is you don't know. All right, and then we'll have our test on Wednesday. Thank you. Good luck. Enjoy the beautiful weather.
Hey, Dennis.
Yes,
I've been doing all of my homework on like a Google Doc and putting it on a folder.
sure.
So when it comes time to turn it in, do you want me to like print it out and put it in a physical folder?
That's right.
And so like I won't have, because I did the notes on like paper.
Yeah.
So
It'll be all right.
okay. I just wanted to.
Actually, you know what? We're still doing COVID safe stuff, and let's not kill a tree. You can probably just send me a link. I'll
Okay.
think about that.
Awesome.
You
Thank
can
you.
probably just share the link.
I have a question about the extra credit.
Yes,
So is that gonna be added at the end of the semester?
yes.
Okay, thank you. I was
So,
wondering why.
Don't worry, you'll get it.
Okay, thank you so much.
Hey,